Hello and welcome to Mr. Tompkins EdTech. This video covers all the harder, higher tier topics from GCSE Maths in just over 2 hours. I've already covered all the essential crossover topics appearing on both foundation and higher papers in this earlier video. So if you're just starting out in your revision, you might like to go and watch that one first, link below. This video covers all the more demanding topics and question types normally found in the final third of the paper, and is aimed squarely at higher tier students aiming for grades 7 through 9. So if that sounds like you, then keep watching. You'll find a list of all the topics covered in the video description below, along with timestamps to help you navigate through the video. As you progress, I highly recommend you use the topic list to make a list of any topics that you're not sure about. Afterwards, you can then look up those topics in your revision guides or simply follow the links provided to more focused revision videos on those topics. This is a long video, so make sure you take regular breaks or split it up over a couple of revision sessions. If you find it helpful, please do like and subscribe and share it with your friends. The more past paper practice you do, the better prepared you'll be for the final exams. You'll find video walkthroughs of pretty much every exam paper on my channel, along with revisions, resources and question compilations on all those key topics you struggle with. Make sure you check those out, as this video on its own is no substitute for thorough preparation. As we run up to the exams, I'll be posting important information, predicted questions and general support and encouragement to help you achieve your target grade this summer. Good luck in your preparations and in your exams. Let's get into it. Write 7/11ths as a recurring decimal. Okay, so we need to divide 7 by 11. So I'm going to do it by short division, I think. 7. I'm just going to make it 7.0000 so we can get an idea of what the pattern is like. So 11s into 7, they don't go, do they? So that's going to give me 0 up there, and I'm going to carry the 7 over into the next column. So 11s into 70, well 6 11s are 66, aren't they? So it can go in 6 times. And then the remainder is going to be 4 then, isn't it? Okay, 11s into 40. Well, 3 11s are 33, so it goes in 3 times. Remainder, well, 33 from 40 is 7. Okay, and then we've got 11s into 70 again, so that's going to give me another 6. And then after that, it's just going to be bouncing between 6 and 3, isn't it? 6 3 6 3 6 3 and so on. Okay, so we've got the pattern now, so we can then write that down as a recurring decimal. So it's going to be 0.63. The pattern starts here, stops here. These are the two ones that are repeating, aren't they? So 6 3 6 3 6 3. It's like that. B, convert 0.36 reoccurring into a fraction, given your answer in its lowest terms. Okay, so now we've got 0.36666. I'm just going to write that down. Okay, so I'm going to write x is equal to 0.366666 and so on, an infinite number of 6's. So if x is equal to 0.36666, then 10x, that's going to be 3.666666 and so on. And 100x, just add in another, I'm multiplying that by a factor of another 10, is going to give me 36.666666 and so on. Okay, so then if I subtract 10x from 100x, it's going to leave me with 90x. And I hope you can see that if I subtract 3.6 reoccurring from 36.6 reoccurring, then my recurring decimally part is going to disappear from both, and I'm left with 36 subtract 3 then, aren't I, which is going to be 33. So that means that 90x has got to be 33. So x, just dividing both sides by 90, is going to be 33 over 90. The cost of a ticket increases by 10% to £19.25. Work out the original cost. Okay. Now I always do my percentage questions using this triangle, final, original, multiplier. You just cover up the one that you want to find, and then that will give you the equation that you need. So here, final, well, I'm working backwards, aren't I? So I've been given the cost after the increase. So the final is 19.25. The original is what I'm trying to find. And the multiplier, it's a increase of 10%. So if I start with 100 and I add on 10, I've now got 110%, which as a multiplier is 1.1, isn't it? Okay, so I want the original. So let's cover that up. And that means my original is equal to final divided by multiplier. Original equals final divided by multiplier, which in this case is £19.25 divided by 1.1. This is a reverse percentage question, isn't it? If you do it a different way, 19.25 divided by 1.1 on my calculator comes out to be 17.5. This is in pounds and pence though, isn't it? So that's £17.50. I have to put that extra zero on if it's money, otherwise you lose an accuracy mark. So my answer is £17.50. The number of gannets on an island is assumed to follow the exponential growth model. N equals 0.45 times 1.07 to the power of x. It's a little bit like compound interest, and it's interesting we've had a second question on the same topic here. N is the number of gannets in thousands, x is the number of years after the 1st of January 2010. Complete the table for N. Okay, now again, if you've got one of these nice Casio calculators, you can use the table function in here to work out what all the values are in these missing tables. It's quite handy. I'm going to quickly show you how to do it. So click menu, select the table option. Now the first thing that pops up is f of x. Now this is the function that you need to be putting in. Okay, so here I'm going to type in the bit after the equal sign. So it's going to be 0.45 times 1.07. Use the power button, and then up there I need to write the x. Now the x, you can see, is written in red above the right bracket. So to access it I need to press the alpha key, and that should pull up my x. Okay, so I've written in my function f of x, and it's what n is equal to in the paper. Right, when I press equals, if you've got the newer Casio model, you'll get an option for g of x. If you've got the older one, it will just skip over g of x. You can only put one function in. I'm not going to use the second function, so I'm just going to press equals again. Then it asks me start, end, and step. I'm going to be starting at 0 because that's my lowest value of x in my table. I'm going to be ending at 20 because that's the highest value of x in my table. And you notice the values in x are going up in 5s. So that's what the step is what you're going up in. So I'm going up in 5s. So if I press equals again, you should see it then generates a table for me. The first column has got my x values. You see it's got 0, 5, 10, 15. And if I scroll down, I'm going to get the next ones as well. And next to it in the f of x column, I've got the values of the function. Now you should be reassured to see that the first two match up. So I've got 0.45 for 0. I've got 0.63 and a bit more detail for 5. At 10, I've got 0.8852. So all these numbers are rounded to 2 decimal places. So I'm going to do the same thing. I'm going to round off that. I'm going to write in 0.89 under there for 10, 0.89. And then I got my 15 value. You should be reassured again that matches up with the one that's in the table. And then finally, I've got my 20 value, which is 1.74. I'm going to write that in, 1.74. Okay, job done. Thank you, calculator. Again, highly recommend you get a Casio calculator that looks like this one if you haven't got one already. And as mentioned before, there is a link below to my Amazon page where you can find this calculator and other recommended stuff for your exams. Okay, in part B, I need to plot these points then. So let's just have a quick look at the scale. From 0 to 0.5, we've got 5 little squares. So each one of these divisions is 0.1, isn't it? So that'd be 0.1, 0.2, 0.3, and so on. Okay, it's important that you understand the scale before you start plotting points. Okay, so the first point I need to plot is 0 against 0.45. Okay, try and make sure you're using a single line. Mine's a bit wobbly, that doesn't really matter so much. What you will get marked down on is feathering, so like when you have like multiple lines like that can lose you mark. Or missing the points entirely, so not actually going through the points will cause you to lose marks. Okay, but it should look something like that. Okay, and then finally it says use your graph to find the year when the gannet population is predicted to reach 1,000. Okay, so this scale and it's in thousands, isn't it? So 1,000 is going to be here. Okay, so if I can then get my ruler out and read across from 1 or 1,000 until I hit my line. So read across from 1 till you hit the line. When you hit the line, I'm going to change direction and read downwards. Okay, so the answer I'm looking for is there then, isn't it? So it's a little bit more than 11. So what, 11? Should I go for 11.5? I think I'm going to go for 11.5 there. So use the graph to find the year when the gannet population is predicted to reach 1,000. Okay, well I think 11 is somewhere between 11 and 12, isn't it? But 11 it won't quite have reached 1,000. It will be a little bit below. So I'm going to go for 12. So that's 12 years after the 1st of January 2010. So 2010 plus 12 is going to be 2022. So I'm going to say 2022 is my answer. Now, if you'd have rounded the other way to 2021, I think you would probably get the mark in this. In a village, the ratio of males to females is 2 to 1. 40% of the people in the village are right-handed males. 25% of the people in the village are right-handed females. Show that the proportion of females who are right-handed is greater than the proportion of males who are right-handed. Now, students often find these sort of questions tricky because there's not a number given for the number of people in the village. So you're finding, they're thinking 40% of what, or to divide what in the ratio of 2 to 1, and it's difficult for them to come up with an answer. So often I think it's useful just to assume a number of people that you're talking about. Now often when it's percentages like this, I would assume there are 100 people and then divide it up into 40 and 25, whatever like that. But the difficulty here is I've got a ratio up here of 2 to 1 and it's difficult to divide 100 up into 3 parts. It doesn't divide nicely. So I'm going to assume then that there are, I'd normally go for 100, but it doesn't divide by 3. So I'm going to go for 300. So I'm going to assume 300 people in the village, just so that I can do the calculation without worrying too much about it. Okay, so then I've got, so let's say all of these, this bar here is all the people in the village. It's 300 people, isn't it? So if I divide that up into 3, then I've got 100, 100, 100, haven't I? So then that there would be the females. And there's 100 there. And then this would be the males then, wouldn't it? There's 200. There's twice as many males as there are females. Okay? 40% of the people who are in the village are right-handed males. Okay, so if I take that same bar then, which is made out of 300, and I want to find 40% of it, that's going to be 3 lots of 40 then, isn't it? It's going to be 40, 40, 40, which is 120. Okay, so of my 200 males, I'm going to have 40 times 3, 120 of those who are right-handed. And then the lefties are going to be the remainder, isn't it? It's going to be the 80 that are left. Okay. Now in my female bar, which is of length 100, 25% of the people in the village are right-handed females. So 25% of 300 is 25, 25, 25. That's 75, isn't it? So this bar here, I'm going to divide up into 75 righties and 25 lefties. Okay, so show that the proportion of females who are right-handed is greater than the proportion of males who are right-handed. Okay, so the proportion of males who are right-handed is going to be these guys here, this 120, as a fraction of the males, and isn't it? Okay, so the proportion of right-handed males is going to be 120 over 200, and that is equal to, well, it cancels down, doesn't it? That's 60 out of 200. That's, sorry, 60 out of 100, that's 60%. So 60% of the males are right-handed. And then for females, so right-handed females, that's going to be my 75 right-handed females out of a total of 100 females, then, isn't it? So that's going to be 75 over 100, which is 75%. Okay, show that the proportion of females who are right-handed is greater than the proportion of males who are right-handed. Well, 75% is bigger than 60%. So I think that's enough. We've shown, we found the proportion of men who are right-handed and the proportion of women who are right-handed, and we've seen that one is bigger than the other. So I think that's enough. The area of a rectangle is 56 square meters. Correct to the nearest square meter. The length of the rectangle is 9.2 meters. Correct to the nearest 0.1 meter. Calculate the smallest possible width of the rectangle. Okay, now take care. This is a limits of accuracy question. I can tell because of those two statements there that it's correct to the nearest so and so. Okay, so don't just go and divide 56 by 9.2 and think you've got the answer. No, no, no. First off, we need to work out what the limits of accuracy are on these two values. Let's take the area first. Now, I like to draw a little number line, mark on the number they give me, 56. Now this is given to the nearest meter. What's 1 meter more? 57. What's 1 meter less? 55. Okay, so which ones round to 56? Well, the numbers that round to 56 are the ones that are halfway between or closer to 56. So this area here rounds to 56. Okay, and what are those halfway values? Well, halfway between 55 and 56 is 55.5, and halfway between 56 and 57 is 56.5. Okay, so they're my upper and lower limit for the area of this rectangle. Okay, now the length, similarly, if I draw a line, mark the one I've been given, 9.2, correct to the nearest 0.1 meter. So using that scale, the next number up on that scale would be 9.3, and one below would be 9.1. Okay, Now, which numbers round to 9.2 correct to 0.1 meter? It's going to be the ones that are halfway between those two or closer, this area here. Okay. What numbers are halfway between 9.1 and 9.2? Well, that's going to be 9.15 and 9.25. Okay. Now, when we're working out, well, we need to work out the width, isn't it? So area equals length times width, normally. So then width is going to be area divided by length. Width equals area over length. Okay. Now we want this to be the smallest possible value that it can be. Okay. So which of these values up here in my diagram do I need to pick in order to deliver that smallest possible width? Okay. Now, with the numerator, I'm going to have to pick the smallest possible area to get the smallest possible width. So this one here, I'm going to pick 55.5, the smallest possible ones. Okay. Now, to get the smallest possible width, I need the biggest possible divisor here to get the smallest possible number. If you think of it, a fraction, the smallest fraction is the one with the largest denominator. So a quarter is smaller than a half because a 4 is bigger than a 2. So I need to pick the biggest. So I need to pick the largest possible length, which is my 9.25. 9.25. Now, if you can't kind of figure this out or reckon it out in your head, then the other thing you can do is you can just try each possible combination. So try that divided by that, that one by that one, that one by that one, until you get the lowest possible result. That's another way of going about it. But I'm a bit lazy, so I like to just figure it out and then just do it once. 55.5 divided by 9.25. That comes out to be exactly 6. That's weird. So it is exactly 6. 6 what? 6 meters. Okay. Any other combination is going to give me a bigger value for width, isn't it? So if I picked any other combination of those lengths, it's going to come out bigger than 6. So 6 is my smallest possible width of the rectangle. Work out 16 to the power of -3/4. Now, -3/4. This is quite a complex index, -3/4. But I take each one of these as 3 separate steps. So I've got a negative sign, I've got a denominator, and I've got a numerator. And I'm going to deal with them as 3 separate operations. Okay, so first off, the negative sign. A negative index means 1 over that thing. So rather than having 16 to the power of -3/4, I'm going to deal with the minus sign and say that's the same thing as 1 over 16 to the power of 3/4. Okay? So I've dealt with 3/4. So I've dealt with one of the bits, haven't I? So now let's look at this number on the bottom, the 4 there. That means the 4th root of 16, isn't it? So the 4th root of 16, it's got to be 2, isn't it? 2 times 2 is 4, times 2 is 8, times 2 is 16. So the 4th root of 16 is going to be 2. So that's the same thing as 1 over 2 to the power of 3. So I've dealt with the negative sign, I've dealt with the denominator. Now I just need to deal with the numerator of that index. So power 3, 2 to the power 3, 2 cubed. And that's just going to be 1 over 8. So it's 1/8. Okay, so these complex indices, just break them down into 3 separate steps. Do one after the other. So 4 to the power of x is 8 to the power of 2/3. Okay. Let's try and make the bases the same for both these numbers. 4 is the same thing as 2 squared. So 2 squared to the power of x is equal to 8. Now 8 is 2 cubed. So 2 cubed to the power of 2/3. Okay, so when you've got an index and an index like that, you multiply them together. So that's the same thing as 2 to the power of 2x is equal to 2 to the power of, what's 3 times 2/3? That's just 2, isn't it? So 2 to the 2x is equal to 2 to the 2. So then equating our indices, because the bases are the same. These two bases are the same, look, they're identical. So it means I can equate the indices. So 2x must be equal to 2. So x is equal to 1. Simplify the square root of 80 plus the square root of 2 2/9. Give your answer in the form of a root 5 over b, where a and b are integers. Fun. Okay, so root 80. Now, if I take 5 out of 80, 80 is 5 times 16, isn't it? So root 80 is the same thing as root 16 times 5. And I've got plus 2 2/9. So that's a mixed number, isn't it? What's that as a top-heavy fraction? 2 times 9 is 18, plus 2 is 20. So that is the same thing as 20 over 9, all square rooted. Okay. So that first one, root 16 times 5, I can break that up into two different roots. The root of 16 times the root of 5. The root of 16 is 4, so that is 4 root 5. And on the other side, I can split that up into two roots. I can say that is the root of 20 divided by the root of 9. So that is the root of 20. The root of 9 is 3, isn't it? So it's that. So I've got root 20 over 3. Is that helping me? Okay, now 20 I can make to be 4 times 5, can't I? So if I leave that one for now, 4 root 5 plus the root of 4 times 5 instead of root 20. Then I can break that up into two separate square roots, and the square root of 4 is 2. So that's going to leave me with 4 root 5 plus 2 root 5 over 3. Okay, so we're almost there. So what can we do about this fraction on the left? If I want to put this over a common denominator, if I take 4, if I multiply top and bottom by 3, it's 4 over 1 at the moment. So if I multiply it by 3 by 3, then I'm going to get 12 root 5 over 3. So that is equal to 12 root 5 over 3 plus 2 root 5 over 3. So now I've got two fractions with the same denominator. So I simply add the numerators together. So 12 root 5 over 3 plus 2 root 5 over 3 is going to be 14 root 5 over 3. So it's in the form of a root 5 over b now, isn't it? Where a is 14 and b is 3. Right, root 12 plus 15 over root 3 in the form a root b, where a and b are prime numbers. Okay. So let's see if we can rationalize that second part of the fraction first. 15 over root 3 multiplying top and bottom by root 3. It's going to give me root 3 times root 3 is 3. 15 root 3 over 3, like that. Okay. Now you can see that I can divide the 3 now into the 15, leaving me with 5. So that is equivalent to 5 root 3. Now my root 12 part, I can rewrite root 12 as 4 times 3, root of 4 times 3, and then I can break that up into two separate fractions, or two separate surds. Root 4 times root 3. Root 4 is 2, so that leaves me 2 root 3. So my original sum of root 12 plus 15 over root 3
is the same thing as root 12, which is 2 root 3 plus 5 root 3, which gives me 2 root 3 plus 5 root 3 is 7 root 3. So my answer is 7 root 3. So A and B are both prime numbers. So that's all good, all done. Work out the value of root 2 to the power of 4. Well, root 2 is same as 2 to the power of a half. So I've got 2 to the power of half raised to the power of 4. Now when I've got an index of an index like that, we multiply the indices together. So it's 2 to the power of half times 4, which is 2 to the power of 2, which works out to be 4. Expand and simplify root 2 plus 3 all squared. So root 2 plus 3 all squared is going to be these two brackets multiplied together. Now use first outside inside last, or whichever way you remember how to multiply out double brackets. I'm going to get root 2 times root 2 plus 3 root 2 plus 3 root 2 plus 3 squared, which is 9. Root 2 times root 2 is 2. Alright, root 3 there. 3 root 2 plus 3 root 2 is 6 root 2 plus 9. So 2 plus 9 is 11. So it's going to be 11 plus 6 root 2 is our solution. Work out 5 times 10 to the 4, subtract 1.6 times 10 to the 3, give your answer in standard form. Okay, so similar to the last question where we couldn't add or subtract our fractions unless they had a common denominator. If you want to add or subtract numbers in standard form, it's handy to have this last part here the same, the power of 10 the same. And you'll notice they're different in this case. I've got 10 to the 4 and 10 to the 3. But 10 to the 4 is just 10 times 10 to the 3. So I can take a 10 out of 10 to the 4 and instead multiply. So if I reduce that by 1, I can times the mantissa part, the number part, by 10. So that's going to give me 50 times 10 to the 3, subtract 1.6 times 10 to the 3. Now notice now that the exponent part, the power of 10, is the same in both. So that means I can just subtract the mantissa part, the number part at the front, one from the other. So 50 subtract 1.6. That's 48.4, isn't it? So that's going to give me 48.4 times 10 to the 3. Okay, are we done? Not quite. It asks us to put our number in standard form, and this is not in standard form because my number part at the front is not a number between 1 and 10. So again, I'm going to take that 10 out that I multiplied it through by a minute ago. So they're going to divide the mantissa by 10, so it's going to give me 4.84 and kind of combine it in with the 10 to the 3. So 10 to the 3 times 10 is 10 to the 4. Okay, so now my number is in standard form. I've got the first part of the number as a number between 1 and 10, and then I'm multiplying through by a power of 10. Good, let's move on. Here are the first 4 terms of a quadratic sequence. You've got 0, 9, 22, and 39. The nth term can be written as an squared plus bn plus c. Find the values of a, b, and c. Okay, so when we've got a quadratic sequence, it's the second difference, isn't it, that is constant. So if you have a look at the difference between 0 and 9, that's plus 9. 9 to 22 is plus 13. And then from 22 to 39 is plus 17. But if you look at the second difference, 9 to 13 is plus 4, and that is plus 4, and it will be plus 4 all the way up from there. Okay, so that plus 4 tells us that our sequence, our nth term is going to have something to do with half of that squared. So it will be 2n squared, which is the squared part of this sequence. So what you do is you calculate that second difference and divide it by 2, and that's going to give you the coefficient of n squared that you're going to get at the front there. Okay, so we've got the sequence 0, 9, 22, and 39, and it's got something to do with 2n squared. That's going to be a component of the nth term. Now, what is 2n squared? So for 1, n is 1, 2, 3, and 4. 2n squared is going to be, well, 1 squared times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. And 4 squared is 16 times 2 is 32. Okay, so if I take that out of our sequence, what have we got left? So I've got 0 subtract 2, that's minus 2. 9 subtract 8 is 1. 22 subtract 18 is 4. And 39 subtract 32 is 7. Okay, so my sequence has got something to do with 2n plus 2n squared, but that's not the whole thing. I've also got this part remaining, which is going to be a linear sequence, isn't it? Can you see what this is a linear sequence in? That's plus 3, plus 3, plus 3. So it's got something to do with 3n then, isn't it? Okay, so that's going to be the second piece of our puzzle, 3n. But 3n is 3, 6, 9, 12, and not minus 2, 1, 4, 7 is what I had before. So actually, what we've got there, minus 2, 1, 4, 7, is the sequence 3n subtract 5, isn't it? Because 3 subtract 5 is minus 2, and 6 subtract 5 is 1, and 9 subtract 5 is 4, and 12 subtract 5 is 7. Okay, so that's my 3 bits then, isn't it? So the 2n squared and the 3n and the minus 5 then make up my sequence. Okay, so in the form an squared plus bn plus c is 2n squared plus 3n minus 5. Okay, in other words, a is equal to 2, b is equal to 3, c is equal to minus 5. Okay, that's my solutions. A, b, c. And I've got 3 brackets, x plus a, x plus 3, and 2x plus 1, and we're told that is equal to b cubed, bx cubed plus cx squared plus dx minus 12. And we need to find the values of a, b, c, and d. Okay. So what we're going to do here is I'm going to take the side with all the brackets. I'm going to multiply it all out, and I'm going to compare it with the other side and see if I can work out what the values are by comparing, using a technique called comparing coefficients. So let's start by multiplying out these brackets. I'm going to start with the left hand side, which is x plus a, x plus 3, 2x plus 1. Okay, now I'm going to do FOIL on the first pair of brackets, first, outside, inside, last, or 2 eyebrows, a nose, and a mouth, whichever way you remember it. So that's going to give me x squared plus ax plus 3x plus 3a. And then I need to multiply that by 2x plus 1 still. Okay, so now everything in the first bracket, it's not so easy to collect them together just yet. So everything in the first bracket I need to multiply with everything in the second bracket. So I'm going to take everything in the first bracket and multiply it first by 2x. So x squared times 2x is 2x cubed, and then ax times 2x is 2ax squared, and then I've got 3x times 2x, which is 6x squared, and then I've got 3a times 2x, which is 6ax. Okay, so I've multiplied my 4 terms in the first bracket by 2x. I'm now going to multiply through everything by 1. So 1 times x squared is, what's that going to be then? That's going to be x squared. And then 1 times ax is AX. And then 1 times 3x is 3x. And then 1 times 3a is 3a. You notice I've kind of staggered it as I've gone through, because I'm kind of use it to help me collect like terms together a little bit. So I've got 2x cubed, I've got 2ax squared plus 6x squared plus another x squared. So that's going to be 2ax squared plus 7x squared. Might have been easier if I'd have written that under that one. And then I've got 6ax plus ax, which I make to be 7ax. And then I've got 3x by itself and a 3a by itself. Okay. So going through this a bit more carefully now. Now I've got various terms here in x squared and x cubed and x and constants, which I'm going to kind of group up together. So first off, I've got 2x cubed. I've only got one term in x cubed, so that can just stay as it is at the front. 2x cubed plus I've got a 2ax squared and a 7x squared. So in terms of what I've got in terms of x squared, I've got a 2a plus 7 lots of x squared, just factorising the x squared out of those two. Okay, so my 2x cubed is that one, my 2ax squared and my 7ax went into there, look. And then my next one, I've got 7ax and 3x, so those two terms have both got to do with x. So again, I'm going to factorise it, so I'm going to write 7a plus 3 lots of x. So that was that term, and that term are included in there. And then finally, I've got a 3a on the end, which is my constant, isn't it? Okay. So I've got 4 terms now, a term in x cubed, a term in x squared, a term in x, and a constant. Now, if you remember to go back the right-hand side of this this equation, I was told earlier that this thing was equal to bx cubed plus cx squared plus dx minus 12. Okay, so kind of labelled these a little, kind of highlighted these a little bit in precisely. I got 2 as the coefficient of x cubed for my left hand side, and my right hand side I had a b. Now if these two expressions are the same, then they got, each part of these has got to be the same. So my 2x cubed has got to match up with my bx cubed, which means b then must be equal to 2. Okay. From looking at the coefficients of x squared, my left hand side had 2a plus 7, and my right hand side has got cx squared, isn't it? So 2a plus 7x squared must be the same thing as cx squared, and so I can also equate those together. I can say that c is equal to 2a plus 7, and then the next part along, I can see that I've got 7a plus 3 lots of x, and I know that's the same thing as dx, so I can say that d must be equal to 7a plus 3. And then finally I've got 3a, and that is equivalent to 12. So I can say that 3a, oops, 3a equals minus 12. Just need a little bit more working space. Let me just scroll up a little bit. So 3a equals minus 12, that makes a equal to negative 4. Now once I know that a is negative 4, I can then find c and d then, can't I? So a is negative 4, c is 2 lots of a plus 7, so subbing in my values of a, 2 lots of minus 4 is minus 8 plus 7 is negative 1, isn't it? So c is negative 1, and d D is going to be 7 lots of -4. 7 fours are 28. Minus 28 plus 3 is -25. So I've got A is -4, B is 2, C is -1, and D is -25. I'm asked to write x squared plus 6x plus 10 in the form of x plus A all squared plus B. In other words, we need to complete the square. So in order to complete the square, the first step is to take this number here, the coefficient of x, and halve it. So half of 6 is 3. So I can then rewrite the first two terms, x squared plus 6x, as x plus 3 all squared. I then need to take off a square of this number here, otherwise they won't actually be equivalent. So that'd be minus 3 squared, which is 9. And then I've got the plus 10 to add on, because I haven't dealt with that yet. So I get x plus 3 all squared minus 9 plus 10 is plus 1. Okay, so our value of A is 3 and our value of B is 1. 22b says, hence write down the coordinates of the turning point of the curve y equals x squared plus 6x plus 10. Now you notice that's the same expression as we had in part A. Now, if I have an equation of the form y equals x minus a all squared plus b, then that will have a turning point of AB. So that would be the point there on the graph. So here we worked out our equation in complete square form was x plus 3 all squared plus 1. So here we're going to have y equals x plus 3 all squared plus 1. So you can see our value of A is going to be, well, the flip sign of that's going to be minus 3. And our value of B is going to be 1. So A equals minus 3. And B is equal to 1, like that. Factorize fully 9y cubed minus 6y. Now notice the word fully, when they add that word in there, it means that there are more than one factor to find. So if you only pull out one factor, you won't get both marks. If you have a look at 9y cubed and 6y, you can see there are two factors that you can pull out. 9 and 6 are both multiples of 3. And y cubed and y both have a y in them, so I can take 3y out as a common factor of both those terms. 3y times 3y squared is going to give me 9y cubed, and 3y times 2 is going to give me 6y. So that's what I'm getting. That's what I'm going to get. 3y squared minus 2. 16b, factorize 3x squared minus 22x plus 7. Okay, so when you factorize a quadratic, it's going to go into double brackets like this. Looking at the first term, 3x squared, I can only really get 3x squared by multiplying 3x and x together. Note the minus and the plus. So my two numbers multiplied together are going to give me a positive value, and when I add them up, I'm going to get a negative value. That can only happen if they are both negative. And then finally looking at the number on the end there, that's 7. 7's prime, it's only got one factor pair, which is 1 and 7. So which way round do they go in? I can either put the 7 here and the 1 here, but that would give me, what would that give me? That would give me minus 3x minus 7x, give me minus 8x in the middle, which is not what I want. So it's got to be the other way around. Let's try it with the 1 here and the 7 here. Then my 3x times my minus 7 is going to give me minus 21, and minus 1 times 1 is going to give me another x, giving me minus 22x altogether. So that is the solution then, isn't it? So 3x minus 1, x minus 7 is the answer. Solve this equation algebraically. Give your solutions correct to 2 decimal places. I've got 3x squared plus 8x minus 5 equals 0. Now, I've not quite seen these questions worded this way before. Solve this equation algebraically. A bit of a weird wording. Presumably they just mean use of formula. I think it's going to be formula rather than by factorising, because of this bit here, correct to 2 decimal places. So I'm going to assume that it doesn't factorise nicely, and I'm going to be using the formula. Okay, so the formula says that this coefficient is A, this one is B, and this one is C, and the formula I'm going to be using is x equals minus b plus or minus the root of b squared minus 4ac all over 2a. Okay, so subbing into that then, so remember this one up here is, so 8 is b, minus 5 is c, 3 is a. Okay, so we're going to just sub that in carefully into the formula and then work it through to a solution. So minus b is going to be minus 8 plus or minus the root of b squared, 8 squared, minus 4 lots of 3 lots of minus 5 all over 2 lots of 3. Okay, just simplifying that down again. So minus 8 plus or minus 8 squared is 64. So minus, 64. And then I've got minus 4 times 3 times minus 5. So I've got minus and minus, which is going to be a plus. And 4 times 3 times 5, 12 times 5 is 60. Divided by 2 lots of a, which is 6, 2 lots of 3, which is 6. Okay, so just finishing off, minus 8 plus or minus 124 all rooted over 6. Okay, now at this point I can sub it into the calculator and work out my 2 values then. Okay, so carefully typing into the calculator, I'm going to use the fraction button, negative 8 plus the root of 124 to start with, divide by 6, what's that? Okay, thank you, it's told me it's the same thing, pretty much. 0.52 to 2 decimal places, 0.52 then, isn't it? So x equals 0.52, or I'm just going to use the back button, and I'm going to zip across to where that plus was, delete it and put a minus in. Okay, press enter again, and that gives me minus 3.1. I'm going to have to round it up that time, aren't I? So it's going to be minus 3.19. Minus 3.19 to 2 decimal places. Okay. Okay, so in this question we need to rearrange this equation to make x a subject. Now note that x is appearing in 2 separate places here. So somehow we're going to have to get these 2 things to join up again in order to make x a subject. Okay, so let's start with what we've got. Y equals 4 minus 3x over x minus 5. First thing I can do is cross multiply this x minus 5 to the other side of the equation, giving me y lots of x minus 5 is equal to 4 minus 3x. Okay, removing the brackets, I get xy minus 5y equals 4 minus 3x. Collecting all the terms to do with x on the left and everything else on the right, I'm going to get xy plus 3x equals 4 plus 5y. Okay, then I can factorize x out of my 2 terms. So x, open brackets, y plus 3 equals 4 plus 5y. And then finally cross multiplying the y plus 3 is going to give me x equals 4 plus 5y all over y plus 3. Which is the answer I'm going to write in the box. Show that this thing is equal to that thing. Okay, now with these algebraic ones where you have to show that things, what you don't want to do is try and work on everything all at once. It's not an equation that you need to solve. So if you start and try and move things over the equal sign, you are going to come a cropper. What you want to do is you want to take one half of it and show it's equal to the other half. So we're going to take, like, have a look at this side over here, reformulate it so it looks like this one over here. That's what we're going to do. Okay, so we're going to start with the left hand side. So the left hand side of this equation, that is equal to 5 over n plus 3 plus 2 over n minus 1. Okay, now, so when we're adding fractions together, we need to find a common denominator. Okay, so we're going to get that by multiplying these two things together, aren't we? Okay, so put it over a common denominator like that. So how many times does n plus 3 go into n plus 3, n minus 1? It goes in n minus 1 times. So I need to take that 5 and multiply it through by n minus 1. Okay, it's basically that times that, isn't it, on the top, and that times that. Okay, so then 5 lots of n minus 1 plus 2 lots of n plus 3, that's on the top. Okay, now if you have a look at the green box, the bottom bit is looking fine now, isn't it? This is already matching, so I don't have to do anything else with the bottom part. It's the top part I need to get to look like the top part of the other one. So removing the brackets there, that's going to give me 5n minus 5 plus 2n plus 6 all over n plus 3 n minus 1. Okay, collecting like terms on the top, 5n and 2n is 7n, minus 5 plus 6 is plus 1, isn't it? So that gives me 7n plus 1 over n plus 3 n minus 1. Okay, and now the bottom is equal to the bottom and the top is equal to the top. Okay, so we've got our left hand side looking like our right hand side. Okay, and that's it. So we've got our we started with the left hand side and now we've got the right hand side, so that means that the two things are equal to each other. Okay, so with these ones, like I say, if you try and start moving things over that equal sign, it will all go horribly wrong for you. It's not what you do. Take one side, normally the more complicated looking at the two, and try and simplify it, make it look like the other one. Let's move on. We've got a quadratic and a linear equation. So we can't solve these by elimination. It's going to have to be done by substitution. Now you notice that I've got a y here and a y here. So these two expressions are actually equal to each other, aren't they? So I can equate this bit here with this bit here. Okay, because they're all equal. So I can say that 2x squared minus 7x plus 4 is equal to 4x minus 1. Okay, so then we're just going to bring everything to one side. So if I subtract 4x from both sides, it's going to give me 2x squared minus 11x plus 4 is equal to minus 1, and then add 1 to both sides. 2x squared minus 11x plus 5 is equal to 0. Okay, so I've got a quadratic in x squared. Let's see if we can factorize it. Okay, now notice I've got a 2x squared on the front, so I'm going to have a 2x and an x if it factorizes. On the back I've got a 5, so I'm going to have factors 1 and 5 of that because it's prime. They're the only factor pair you can have. Notice it's positive at the end and negative in the middle, so it's going to be minus minus. So if I put 1 and 5 in these brackets, can I get minus 11 out of it? I can if I put the 5 here, because then 2x times the minus 5 is going to give me minus 10x, and the 1 times the x is going to give me 1x, and 10x 1x is going to be 11x. So that kind of works out, doesn't it? So if 2x minus 1, x minus 5 is equal to 0, then that means that x has to be a half, or x is 5. Okay, so they're my two values of x, half, and 5. Don't forget though, we need to find the values of y too. So it's easier to take the easier or the smaller, or simpler of the two original equations I was given. So let's take y equals 4x minus 1. So when x is a half, y is going to be 4 lots of a half minus 1. 4 halves are 2, take away 1 is 1. So y is 1 when x is a half. And when x is 5, y is going to be 4 lots of 5 minus 1. 4 5s are 20, take away 1 is 19. So I get half goes with 1 and 5 goes with 19. Prove that the mean of any 4 consecutive even integers is an integer. Okay, so what's this question about? Now, I could do it with a set of 4 consecutive even integers, couldn't I? Let's just write a numerical solution down. So if I got 2, then the 4 consecutive ones would be 2, 4, 6, and 8. And what would their mean be? So then the mean would be 2 plus 4 plus 6 plus 8 divided by 4 then, wouldn't it? So 2 plus 4 is 6, plus 6 is 12, plus 8 is 20. I'd get 20 over 4, which is 5. Is it an integer? Yes, it is. It's a whole number, okay? Now, it works for 2, 4, 6, 8, but I don't really want to try this over and over and over again for every possible combination of 4 consecutive even numbers. So to prove something like this, you need to use algebra, okay? So rather than just looking at a million different possible solutions, so let's now generalize and say let the first even number be 2x. Okay, I'm writing 2x, so if x is any number like 1, 2, 3, 4, 5, if you double it, it's going to give you 2, 4, 6, 8, so it's going to give you an even number. So I'm using 2x so because it's an even number. Could really use x, but I think it's clearer if I just use 2x. So then let first even number be 2x, so my 4 consecutive even numbers are, then I'm going to get 2x is the first one, then 2x plus 2, then 2x plus 4, and then 2x plus 6, aren't they? They're going to be my 4 consecutive even numbers. Okay, so what's the mean of those numbers then? So then the mean is going to be those 4 numbers added together divided by the total number of numbers, which is 4. So I'm going to take my 2x and I'm going to add on the 2x plus 2 plus the 2x plus 4 and the 2x plus 6. So I'm really just using my first dab at it, my numerical solution, to guide me. I'm just following the same steps, aren't I? Okay, so it helps guide me through to what I'm meant to be doing. Algebra is just generalized arithmetic, so whatever you would do with the numbers, that's what you do with the algebra as well. You just follow the same path. So I'm just following this numerical solution, doing exactly the same things. Okay, but obviously there's bits that you need to do differently, like this bit here, because I need to collect like terms. I've got 2x, 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 and 2x. How many x's is that? That adds up to 4x. No, it doesn't. It adds up to 8x. So 8x, and then I've got plus 2, plus 4, plus 6, which adds up to, what's that, 12? 8x plus 12, okay? And that's all divided by 4, okay, because we've got 4 numbers. Okay, now you can probably see that both 8 and 12 divide by 4. Just going to make that crystal clear by factorising 4 out of the expression on the top. So 4 lots of 2x plus 3 divided by 4 means I can then cancel that 4 and that 4, and that leaves me with 2x plus 3. Okay, so regardless of what x is, the mean of those 4 consecutive even numbers ends up to be 2x plus 3, regardless of what the starting number was. It's always going to be equal to that. And because 2x was an integer to start with, and then I'm just adding another integer to it, it's going to have to be an integer solution, isn't it? So I can say that as 2x is an integer, then 2x plus 3 is also an integer, because if I add a whole number to a whole number, I get a whole number, and therefore I can conclude that the mean of any 4 consecutive numbers is an integer. I've proved it. Okay. So I find it helpful to do a numerical solution first, just to run through the problem and see if it's true for a number. It kind of helps me think of the steps I then need to do for the algebra, which is slightly more complicated, but just following the same path, isn't it? So doing it with numbers first, great tip. You might find it helpful and easier for you then to do it algebraically afterwards. Solve the inequality x squared minus 5x minus 6 is less than or equal to 0. Okay, so I think first off we need to factorize this, don't we? So let's say that's the same thing as 2 brackets multiplied together. So I've got x at the start, x squared, so I'm going to have x and x here. Now let's have a quick look at the constant at the end, negative 6. What are the factor pairs of 6? 6 has factor pairs 1 and 6, 2 and 3. So they've got to be one of my numbers, and we're looking for a factor pair that adds up to negative 5. Okay, so but remember, one has to be positive and one has to be negative. Like 2 and 3 adds up to 5, but we're actually going to be having one positive and negative one. So I actually think the one we're looking for is this pair here, the 1 and the 6, isn't it? So it's going to be plus 1 because, and minus 6. That's going to give me negative 5 in the middle, isn't it? Okay. Now if this was an equation, it would have roots then at negative 1 and positive 6 then. So if I was going to draw a sketch of this quadratic, all quadratics have this kind of parabola shape, don't they? Okay, and then this particular parabola is going to have 2 roots, which we've just kind of worked out, haven't we? So the one on the left, x plus 1, that's going to give you a root of minus 1, and x minus 6 is going to give you a root of 6. So this graph is going to look something like this. So where would the y-axis be? Doesn't really matter. Be somewhere in between. Now we want to know when this function is less than 0. So what sections of the number line for x is this graph negative? Okay. Well, it's below the axis in this section from here to here, isn't it? Okay. On the other sides, here it's above the axis, and here it's above the axis. So it's just those bits between minus 6 and 6 where this function is below the x-axis or negative. Okay, so the region we're looking for is the region between minus 1 and 6. So x then lies between 6 and minus 1. Now I do recommend that you do a sketch like this, because otherwise it gets a bit confusing, and I know many students make mistakes with it. So I do recommend drawing the parabola, working out where the roots are, and then thinking where is that graph greater than or less than 0. I think that's the smartest way of doing it. Okay, so that's my range. X lies between minus 1 and 6. The graph of 3y plus 6x equals 13 is drawn on the grid. Yes, it is. The region R satisfies these inequalities. 3y plus 6x is greater than or equal to 13. So that's related to the graph we've already drawn, isn't it? It's well, one side of it or the other. And then we've got y is less than or equal to x minus 2, and x is greater than 3. Okay, so we're going to draw the equations. So this one we've already done, haven't we? We've already got that one on the graph. So let's draw on y is equal to x minus 2 and x is equal to 3 onto the graph, and then we can decide which side of the line we're interested in. We'll do the easiest one first. X is equal to 3. That's just a vertical line through x is equal to 3, isn't it? So let's just draw that one on first. Now this one is greater than, strictly greater than, so I'm going to draw this one as a dotted line. The reason for that is the points on the line themselves are not part of the region because it's strictly greater than 3. Okay. The other one, y equals x minus 2, I can draw it as a solid line. Y equals x minus 2 means it goes through the point minus 2 with a gradient of 1. Okay, now if you're not quite so good at drawing these, you can do a table of values if you want to. So x, y, you know, just pick some values, minus 2, 0, 2, and then find out the values of y that go with it and plot those points. Minus 4, minus 2, 0, you can plot those on. I just tend to use the intercept and the gradient to draw my line, so I know it's going to pass through minus 2 and have a gradient of 1, so I know it's going to look like that, so I'm just going to use that to draw my line. Okay, so which area then, which part of this are we interested in? You can see we've got all sorts of regions that have been created. We want to find the one that satisfies all these inequalities. So we want x is greater than 3, so actually it's got to be to the right of this dotted line, isn't it? Okay, so we don't want the bit to the left of the dotted line because we want x is greater than 3. But is it that bit at the top there? Is it the bit in the middle? Is it there in the bit at the bottom? What's sometimes handy is to pick a reference point. So I'm going to pick that point there, 4, 0, and I'm going to sub it in each of the inequalities to see if it's true or not. So I'm going to try 4, 0. If x is 4 when y is 0, then does 3 lots of 0 plus 6 lots of 4, is that greater than or equal to 13? Okay, well, that's 3 lots of 0 is 0, 6 times 4 is 24. Is 24 greater than or equal to 13? It is. Okay, so it seems to meet that rule. Okay, let's just try the other one. Is when y is less than x minus 2, then 0 would be less than or equal to 4 minus 2. Is that true? Is 0 less than or equal to 2? Yes, it is. Okay, so it is that area there then, because my reference point 4, 0 agreed with both those inequalities, and we already know that 4 is greater than 3, so it meets the third one as well. So yes, it is this region here. So I'm going to label this one here R. Write x squared plus 4x minus 16 in the form x plus a all squared minus b. Okay, so this is in a quadratic expanded form. This one is in what we call the completed square form. It's fairly easy to convert one from the other. What we need to do is we take the coefficient of x here and we halve it. So the coefficient of x is 4, half of that is 2. So we're going to replace x squared plus 4x with x plus 2 all squared. Now x plus 2 all squared is x squared plus 4x plus 4. So we're actually replacing x squared plus 4x with 4 more than we should. So we need to take off a square of 2, which is 4. And then we already had minus 16 there to start with. So then we're going to group those together. So we're going to get x plus 2 all squared minus 4 minus 16 is minus 20. Okay, so that's how it goes. You start by looking at the coefficient of x. In this case it was 4. We halve it. That's the number that appears there. You have to remember that x plus 2 all squared is not a perfect replacement for x squared plus 4x. It's 4 more than you should have. So that is why we then take off that square of 2, which is 4, and then we combine that minus 4 with the 16 to give us minus 20. Okay, so that's what we've done. In this question, all units are in centimeters. A circle has equation x squared plus y squared equals 36. write down the radius and the center of the circle. Okay, well, anything of the form x squared plus y squared equals r squared is going to be a circle centered on the origin of radius r. Okay, so the center of the circle is going to be 0, 0, and the radius, well, if x squared plus y squared equals r squared, and that's 36, then r is going to be the root of 36, is going to be 6. So this is going to be a circle with radius 6 centered on the origin. Now part B says that the distinct points A, which have coordinates a comma root 11, and B with coordinates b comma root 11, lie on the circumference of the circle. Work out the length AB. So let's just draw a slightly bigger sketch so I can add some things onto this diagram. So here's my circle centered on the origin. Now it's got 2 points with height root 11, so they're going to be lying on a straight line, aren't they? So if you imagine a straight line passing through my circle at some point, it's obviously above the x-axis because it's positive, then one of those points is going to be the point A, isn't it? Let's say this one is on the left, and that's going to have coordinates a root 11, and then on the other side here I'm going to have B, which has coordinates b root 11. Okay, what do I want to do? I want to work out the length of that line AB. So I want to know how long that line is. Okay, well, how can I do that? Well, let's add some more lines in. I know that line, that's the radius of the circle, and I know that's length 6, and I know that one as well. That's also a radius of a circle, so that's also length 6, and I know the height of the line above the y of the x-axis is root 11. So I know quite a lot of things about this triangle. So what I think I'm going to do is I'm going to use Pythagoras' theorem in one of the triangles. They're identical to each other, aren't they? They're mirror images. So one of these triangles, like this one, I mean, you're going to use Pythagoras in here to work out the, that top line there, and then I'm going to double it up to find the length as AB. Does that make sense? Let's just call that point there in the middle M, so I've got something to talk about. So, and that's O, it's the origin, and we said that was the point A. So let's have a look at triangle AOM. So in triangle AOM, we're going to be using Pythagoras' theorem. So c squared equals a squared plus b squared, doesn't it? Okay, where c is the longest side, so rearranging it for one of the shorter sides, then a squared is going to be c squared minus b squared. So in other words, the line AM all squared is going to be the long side, 6 squared, minus the shorter side, root 11 squared. Okay, well, 6 squared is 36, root 11 squared is 11, so it's going to be 36 minus 11. Oh, it's 25. Look, that's nice. So then that means that AM is going to be the root of 25, which is equal to 5. Okay, so that one's 5. So this one is also going to be 5. So that means that AB is going to be 2 lots of 5 then, isn't it? So therefore AB is going to be 2 lots of 5, which is 10. Presumably centimetres, because it says all in centimetres. For each of the graphs below, select its possible equation from the list. Okay, and for part A, I've got this very distinctive 2-part curve. Now these sorts of curves are called reciprocal curves, and they're going to have the form y equals 1 over x. Okay, so, or 1 equals 1 over some power of x, actually. So it could be that one, or it could be that one here. Both of those are over x, but this has got an even power of x. When you have even powers, they tend to look like that with the same way up. So you still get a two-part curve, but they're both the same way up. So the one I'm looking for then is that y equals 1 over x. That's the one I'm after, 1 over x. Now question B, when you first look at it, you might be forgiven to think it could be a cubic. Cubics kind of have two turning points, so they start low and end high like that. So you might be thinking it's a cubic curve, but if you have a look carefully down here, this part of the curve starts bending back outwards, and that doesn't happen on cubic curves. If you have a look at this part of my cubic, it doesn't start flaring back out the other way. It gets more and more steep as you get further down the line. So it's not going to be a cubic. It's going to be a trigonometric curve. It looks like a sine curve, doesn't it? Is it sine, cosine though? Because they look very similar. I think it's going to be sine x because it starts at 0, 0. Sine of 0 is 0, whereas the cosine of 0 is 1. So cosine curve starts high like that and then goes down. So it's not cos x, it's going to be sine x, y equals sine x. Okay, and then C, this one is what we call an exponential curve. Okay, so you need to be able to recognize all these graph types. You can tell it's an exponential curve. Look, it passes through 1. It's approaching the x-axis in that direction, and it's kind of zooming up higher and higher in the other direction. So it's going to be one where x is the power. Okay, so I've got two possibilities. I've got y equals 2 to the minus x, or I've got y is equal to 2 to the x. Now, if it's a negative power, it's going to flip it around. It's gonna look more like that if it's y equals 2 to the minus x. So we want 2 to the x, I think. So it's going to be y is equal to 2 to the power of x. And sketch the graph of y equals minus sine x from 0 to 360 degrees. Okay, now y equals minus sine x is a transformation of the graph that you should know, which is y equals sine x. Now the graph y equals sine x, you should have practiced drawing 101 times before your exam comes along. It looks like this, doesn't it? It goes through these points. Goes through 0, 0, 91, 180, 0, 270 minus 1, and then back to 0 there. So the graph kind of gives you a sine curve through those points. So that is y equals sine x. Now, y equals minus sine x. If you put a negative sign in front of it, that's your function of x going to your minus function of x. That is a reflection in the x-axis, isn't it? So basically, every point on your graph is going to be flipped in the x-axis. So points through the origin, points on the axis aren't going to be changed. This one up here at 91, its image point is going to go down here. Then I'm going to go back through there, and then this minus one here is going to be up here, a positive one, and then back to there then. Okay, so sine equals minus, sorry, y equals minus sine of x is the same as y equals sine x, but upside down, like that. Okay, so it looks like that one. Okay, now there's no need for you to draw the reference curve. I did put it in there for just to try and explain why it is what it is, but you could just as well work it out in your head and draw it that way up. That would be perfectly acceptable. I just put the reference curve in to try and explain why it was what it was. Here are sketches of two graphs. I've got graph A and I've got graph of y equals x squared minus 1. The graph of x squared minus 1 is translated 3 units to the left to give graph A. The equation of graph A can be written in the form y equals x squared plus bx plus c. Work out the values of b and c. So the graph of y equals x squared minus 1 is translated 3 units to the left to give graph A. Okay, so if I take a function f of x and I translate it 3 units to the left, that is equivalent of taking my value of x and adding 3 to each value. In other words, where I see x in my equation, I'm now going to have x plus 3 instead. So in the equation y equals x squared minus 1, I'm now going to have y equals x plus 3 all squared minus 1. So the equation then is y is equal to, so where I see x, I'm going to write x plus 3 for my translation of 3 units to the left. And the rest is the same. So x squared minus 1 becomes x plus 3 all squared minus 1. Okay, now I need to rewrite that in the form of ax squared plus bx plus c. In other words, I need to multiply out this bracket, so I can either double it up like that or remember the identity. A plus b all squared is equal to a squared plus 2ab plus b squared, which tends to be the way that I do it. I just remember that identity so I know what to do with these brackets when I multiply it out. So in other words, you get your first term squared, you get your two terms multiplied together and doubled, which is 6x, and then you get your last term squared, 9. So I get x squared plus 6x plus 9, and then I've got my minus 1 from before, which gives me x squared plus 6x plus 8. So comparing that with the form at the top, x squared plus bx plus c, so b is 6 then, and c is 8. Part B says the graph of y equals x squared minus 1 is reflected in the x-axis to give graph B. Work out the equation of graph B. Okay, so when we reflect in the x-axis, our equation f of x becomes minus f of x. Okay, so when you reflect in the x-axis, the y value will switch signs, won't it? So it's minus f of x. So work out the equation of graph B then. So if I take that equation, f of x equals x squared minus 1, and write a minus sign in front of it, then I'm going to get y is equal to minus x squared minus 1. So removing the brackets, I'm going to get y equals, it's going to be minus x squared minus 1, or 1 minus x squared. There's another way of writing it down. F of x equals 5 minus x, and g of x equals 3x plus 7. So we're asked to simplify f of 2x plus g of x minus 1. Okay, so basically when you've got something inside the bracket, that is the value that you're giving to x. So here, f of 2x is going to be 5 minus, going to sub in 2x for x. So that first part is going to be 5 minus 2x, and then plus g of x minus 1. Where I see x, I'm going to write x minus 1. So I'm going to write x minus 1 in there, just like I wrote 2x in there for the first one. So 3 lots of x, which in this case is x minus 1, plus 7. Okay, so simplifying that, I've got 5 minus 2x, multiplying out the brackets, plus 3x minus 3 plus 7. Collecting like terms, I've got minus 2x plus 3x, which is x. And I've got 5 plus 7, which is 12. Take away 3, which is 9. So x plus 9. So it simplifies to x plus 9. Question 28b says solve g to the minus 1 of x is equal to 2x. Now g to the minus 1x is the inverse function. Okay, now we learned earlier that g of x was 3x plus 7. So if g of x is 3x plus 7. And we want to work out what g to the minus 1 of x is. Now let's take that equation 3x plus 7, or that function, and put it equal to y. I'm going to rearrange it for x and then reform the inverse function from that. So 3x plus 7 is equal to y. Let's subtract 7 from both sides. You're going to get 3x is equal to y subtract 7. And then dividing both sides by 3, I'm going to get x is equal to y minus 7 over 3. Okay, so I've made x a subject. So from that, I can tell that the inverse function g to the minus 1 of x is going to be equal to, I'm just going to take this expression here, y minus 7 over 3, and I'm going to rewrite it, but with that one replaced back with an x. So I'm going to write x minus 7 over 3. Okay, so that's my inverse function g to the minus 1 of x. Right, now we're told in the question, or we're asked in the question, to solve g to the minus 1 of x is equal to 2y. So I'm going to take this expression I've just made for g to the minus 1 of x and equate it with 2x. So x minus 7 over 3 is equal to 2x. Okay, now we just need to solve for x. So multiplying both sides by 3, I'm going to get x minus 7 is equal to 6x. Subtracting x from both sides, I'm going to get minus 7 is equal to 5x. So then x is going to be minus 7 divided by 5 then, isn't it? Okay, we've got some iteration here then. So our next term in x, which is xn plus 1, is equal to 4 minus 2 over our last term in x, xn, all squared. So to work out an approximation solution to x equals 4 minus 2 over x squared. So we're going to start with x1 is equal to 1 and feed that into this expression and then work through it. I'm going to have to keep going until our answer settles down into a kind of a consistent answer. Okay, so we know that x1 is equal to 1. So then x2, our next term, is going to be 4 subtract 2 lots of x1, 1 squared. So 1 squared is 1, 2 divided by 1 is 2, and 4 subtract 2 is 2. So x2 is equal to 2. So then we just keep going. So what's x3? x3 is going to be 4 minus 2 over 2 squared, our previous term squared. So 2 squared is 4, 2 over 4 is a half, 4 subtract a half is 3.5. So that's our x3 term. x4 we're going to get by, again, we're just going to keep subbing back in, 2 over 3.5. I'm going to use a calculator now. 3.5 squared. Now, actually, with clever use of our answer key on a calculator, we should be able to feed in this answer very quickly, so we don't have to keep typing it in over and over again. If I press 1 equals first off, that will store the number 1 as my last calculated answer. And then if I type in 4 subtract 2 divided by answer squared, that will take my last calculated value, which was 1, and feed it into this expression. So when I press equals, you can see I got the answer 2, which is what I calculated earlier. But the clever thing is now 2 is now the stored value. So if I just press the equal button again, it will feed 2 into that same expression and then recalculate it. So that gives me my 3.5. So to make this easier on myself, now all I have to keep doing is just press equals, and that will keep giving me the next one. So the next one is 3.84 to 2 decimal places. Let's just, actually I might write it to 3dp to start with so we can see if it's settling down. Okay, so then x5 is going to be 4 minus 2 lots of 3.837 all squared. But I just need to press the equal button. That gives me 3.864. So it's still not quite settled down. So x6 is going to be 4 minus 2 lots of 3.864 all squared. And that is equal to 3.86. 6, 6. So that's going to round up, isn't it? If I round off to 2 decimal places, that's going to be 3.867. So it's still not quite settled down. Let's just do another one. X7 is 3.866 all squared. And you can see now that this time it kind of just settles down on 866 again. Okay, and if I keep pressing it a few more times, you can see that it just stays like that. Okay, so then rounding that off to 2 decimal places, my final answer is going to be 3.87. That's 3.87 to 2dp. A, B, C, and D are points on the circumference of a circle centre O. Angle BAD is 112 and angle DCO is 33. Show that the angle Y equals 35. Give reasons for each stage of your working. Okay, so I just always double check, make sure everything in the question is actually in the answer already. So BAD, is that marked? BAD, yep, that's on there. It's 112, look. Is angle DCO marked? 33. DCO, yeah, that's already on there as well. Just always double check that, because if you're missing a piece because it isn't on the diagram but it's in the question, you could stymie yourself. Okay, but it's all there, so we should have all the information we need. Okay, so how are we going to work out Y? Now with these complicated looking circle theorems, you've got to find a way of kind of fading out a lot of the information and just look for the shapes that you know. Okay, there are certain rules that you should have in your head about circle theorems, and you need to try and focus or see those in the kind of more complex diagram. So for instance, one of the rules that I know about is cyclic quadrilaterals, and I can see a cyclic quadrilateral in this diagram here. Okay, so if I kind of just fade out all the rest of it and concentrate on that cyclic quadrilateral, then I know that in cyclic quadrilaterals opposite angles sum to 180 degrees. Okay, and I've got this 112 angle here, so I can use that then to find this angle from here to here then, because those two should add up to 180 degrees then, shouldn't they? So that's my first thing I'm going to be using. So I'm going to say in cyclic quadrilateral ABCD, then DAB, that angle up there at the top, plus my angle down here, DCB, equals 180, because opposite angles in a cyclic quadrilateral sum to 180. We know DAB is 112, and so we should then know what DCB is, because I can take that away from 180 and find that DCB is equal to 180 minus 112. That's going to be 68. So DCB is 68. Okay, so but I already know DCO, which is part of that angle, so I can then use it to find the other part of the angle, this angle here, then this angle here, OCB, can't I? Okay, so I can say that DCB is equal to DCO plus OCB. Okay, so that's 68 is equal to DCO, which we already know is 33, plus our angle OCB. So that means that OCB then must be 68 minus 33, which is 35 degrees. Okay, so I know that then this is 35 here, but COB is an isosceles triangle, isn't it? I can say that COB is isosceles. Okay, so therefore the other angle OBC is going to be equal to OCB, but the other angle is Y, and OCB I know is 35, so that's 35, so Y is 35. Okay. Next step, I need to work out angle Z. Where's Z? Okay, Z is over here. I'm going to find this one next. Okay, how can I do that? Now again, I'm kind of trying to look for simpler shapes within my kind of complex looking diagram. And I can see that Z is kind of at the tip of one of these shapes here. If you ever watch Star Trek, it's like a Star Trek badge. Maybe you don't watch Star Trek. Anyway, you should know that that tip of a Star Trek badge is always going to be twice that one there, then, isn't it? So that one is going to be 2Z, okay, because it's twice as big. And then I should be able to work it out because I know what Y is and I know what 35 is. So I can easily find that angle there, COB, and then I can halve it to find Z, can't I? So that's my plan of attack. Okay, so I'm going to find Z for that 2Z one. I'm going to work out this one first, and then I'm going to use it to find Z. Okay, so I'm going to say that angle COB is going to be 180 minus 2 lots of 35 then, isn't it? Okay, because my two base angles are 35. So COB is going to be 180 minus 70. It's going to be 110 degrees. And therefore, CDB is going to be 110 divided by 2, which is 55, because angles subtended at circumference are half the angle subtended at the center. Okay, so that's the rule that I'm using. So the trick for circle theorems, as I say, is trying to see those simpler shapes within your more complicated looking diagram. You know, you've got like 4 or 5 of them you need to be on the lookout for. So you need to kind of focus in on those shapes and ignore everything else, and then you should be alright. The diagram shows points A, B, C on the circumference of a circle. Line DAE is a tangent to the circle. DE is parallel to BC. Prove that triangle ABC is an isosceles triangle. Give the reason for each step of your proof. Okay, so what do we know? Right, so this triangle ABC is going to have 3 angles, isn't it? It's going to have one here, one here, one here. Okay. Now, this one up here is the same thing as what? What do we know about it? Well, we've got a pair of parallel lines, haven't we, and a line crossing them. So that angle there is alternate to this one down here, isn't it? So that one is the same. Okay, so we're just going to label it, you colour it in the same colour. Okay. What else do we know? We've got another angle over here. Okay, using the same logic, that is going to be the same as this angle down here. Okay. However, we also know something called the alternate segment theorem, which says the angle between a tangent and a chord drawn at the point of contact is equal to the angle in the alternate segment. So actually that angle there is the same thing as this one up here. Okay, so that means all of these are the same. Okay, so then I've got two angles the same up here, which means this is going to have to be an isosceles triangle then, isn't it? Okay, that's my thinking. Now I need to write that down. So how did we start? And I think I actually went too far. I don't think I needed to go quite so far. I think what I can do instead is I'll go from this one, knowing this one, to knowing this one, and from this one, knowing this one, to knowing that one up there, and then look, then they're equal to each other. I'm done. So I actually did more thinking here than I needed to. I don't need to think about that one. Okay, so starting with this angle up here, BCA. I'm going to start with that angle, and we said that that angle was the same thing as this one down here due to rules about parallel lines, isn't it? It's the alternate angle in a pair of parallel lines. So that's what we can say first then. We can say that angle BCA is equal to angle CAE. And the reason for that is alternate. The alternate angles. Okay? And then what can I say? I can say but CAE is equal to, well, the next thing we said was this angle here is the same thing as this one up here, isn't it? So the angle between the tangent and the chord is equal to the angle drawn in the alternate segment. So that angle there, look, is equal to that one. So CAE is equal to ABC. And we know that from the alternate segment theorem. Okay, alternate segment theorem. Now, so that tells me that BCA equals CAE, which equals ABC. Okay, in other words, BCA equals ABC. Okay, and that means triangle ABC is isosceles. AOB is a sector of a circle, centre O and radius 6. The length of arc AB is 5 pi centimetres. Find the area of the sector. Give your answer in terms of pi. Okay, so we've been given a diagram here for our shape. We haven't, not all the information is on there, is there? We can see that the radius is 6, that's there. We can see AOB, but we've not got the arc length on there, so we need to add that to our diagram. That's 5 pi. So the distance around here, the arc length, is this kind of curved section here, isn't it? So round from there to there, that is 5 pi. Okay, now what we don't have at the moment is this angle here, theta. I think that's probably what we need to find first of all. So we need to find that angle. Once we know that angle, then we can work out what fraction of a circle we've got, and therefore we can work out what the area of that sector is. Okay, so we're going to start with the arc length formula and work backwards to find the angle, and then forward again to find the area. So arc length then is going to be theta over 360 times pi d, isn't it? Pi times diameter, which in other words is 2 pi r. So pi d or 2 pi r. So I'm going to use 2 pi r because we've got the radius here of 6. Okay, so I know the arc length, it's 5 pi. Don't know theta. Hopefully I'm going to find it. And I know that r is 6. Okay, so I've got 5 pi equals pi theta over 360 times 2 pi times 6. Right, I've got pi on both sides. Let's cancel those out. So on the left hand side I've got 5, and on the right hand side I've got theta over 360 times 12. So let's just tidy that up. So 2 times 6 is 12, 12 theta over 360. Okay, now we want to get theta on its own, don't we? We want to work out what the angle is. So let's cross multiply, times in both sides by 360. We'll move that 360 up there, and dividing both sides by 12. We'll move that 12 to the denominator on my other side. So I'm going to get 5 times 360 divided by 12 is equal to theta. I'm tempted to do the division first because that's going to leave me with an easy number to multiply. So how many times does 12 go into 360? Well, 12 goes into 36 3 times. So 12 must go into 360 30 times. So then theta then is going to be 5 lots of 30, which is going to be an angle of 150. So then theta equals 150 degrees. Okay, so now I know what theta is, I should be able to work out the area. So area of sector, so that is going to be theta. So my area is going to be theta over 360 times the area of a circle, which is just pi r squared, isn't it? Okay, so I now know that theta is 150. So I've got 150 3/60ths of pi times r squared. R, remember, is 6. So it's pi lots of 6 squared. So that is going to give me 36 times 150 pi over 360. Okay, I'm going to divide that 10 into that one, give me 15, and 36, and then I'm going to divide the 36 into that 36. So that is going to leave me with 15 pi then, isn't it? So the area then is just going to be 15 pi. We're told that the volume of a cone is 1/3 pi r squared h, where r is the radius and h is the perpendicular height. A cone has a horizontal base of radius 5, a height of 15, and the cone contains water to a depth of 9 centimeters. Work out the volume of the water. Okay, so basically we're trying to find the volume of that frustum part at the bottom. Now a frustum is made up of a cone with a cone taken off the top. So if we can work out the volume of the entire cone, this one, and then we can take away the volume of this smaller cone, we'll be left with the volume of the water. That's the plan. Okay, so a volume of the, should we do it in 3 parts? So the volume of the large cone is going to be 1/3 of pi r squared h. So 1/3 of pi r squared h, which is equal to, in this case, the big cone has got a radius of 5 and a height of 15. So that's going to be 1/3 of pi times 5 squared times 15. Okay, so I can divide the 3 into the 15. That is move 5. And 5 squared is 25 times 5 is 125. So that means that the volume of the large cone then is going to be 125 lots of pi. Okay, so now let's do the smaller cone. Volume of small cone. Now the small cone is this green one up here. Now what we need to do is work out the radius and the height of this cone. Now the height's easy enough. It's the difference between the 9 centimeters and the 15 centimeters. In other words, it's got a height of 6. Now because the large cone and the smaller cone are similar, they have the same angles, etc., all their sides are going to be in the same ratio. So then the radius of the smaller cone is going to be 6/15 of the radius of the larger cone. 6 being the height of the small cone and 15 being the height of the larger cone. That's where the 6/15 comes from, and 5 is the radius of the larger cone. So our smaller cone has a radius of 6/15 of 5. So dividing that out, divide that 5 into that 15 gives me 3 and 1. 6 divided by 3 is 2. 2 times 1 is 1. So the radius of the small cone then is going to be 2. So volume of the smaller cone is 1/3 times pi times r squared times h, which is 1/3. We said the radius was 2. 2 squared, and the height is 6. Again, let's just simplify that out. 3 goes into 6 twice. So, oh, and don't forget the pi. Almost forgot the pi. Let's squeeze that in there. So 1/3 cancels with 6, leaving 2. 2 times 2 squared. 2 squared is 4 times 2 is 8. So basically the small cone has got a volume of 8 pi. Okay, so then the volume of the water is going to be volume of the large cone, take away the volume of the small cone, which is going to be 125 pi, take away 8 pi, which leaves us with 117 lots of. Two cylinders A and B are mathematically similar. Cylinder A has volume of 2,400 cubic centimeters and a height of 12 centimeters, and cylinder B has a volume of 750 centimeters cubed. Find the height of cylinder B. Give your answer correct to an appropriate degree of accuracy. Again, we've got a shape and space question and no diagram. So for me, first thing I'm going to do is quickly sketch what I've got. Okay, so I've got big cylinder equals cylinder, okay, which are mathematically similar. I know that this one is 2400 and this one is 750, and this one has a height of 12, and this one is got a height that I'm trying to find, so I'm going to call it H. Okay, so I've got my two diagrams. Okay, now when you've got two mathematically similar shapes, then the ratio of their lengths and areas and volumes are all related, aren't they? So the ratio of their lengths, let's say it was x to y, then the ratio of their areas is going to be x squared to y squared, and the ratio of their volumes is going to be x cubed to y cubed. Okay, so we've got, well, we know the ratios of their volumes because we've got the values we've got there. We've got 2,400 and we've got 750. Okay, so if we cube root both those numbers, we should be able to find the ratio of their lengths. Now let's just make this a little bit easy to calculate with. If we divide both sides by 750, then I make this second one 1, don't I? So 2,400 divided by 750, according to my calculator, is 3.2. Okay, so the ratio of their volumes is 3.2 to 1. Okay, so that means that the ratio of their lengths is going to be the cube root of 3.2 to 1, isn't it? So cube root of 3.2 to 1. Cube root of 1 is just 1. So the cube root of 3.2, again, according to my calculator, is 1.47 to 1. I'm just going to keep the full calculator display value for now, though, because I need to use that. This is going to be the length, isn't it? The ratio of their lengths. It's going to be 1.47 to 1. So if I then take 12 and I divide it by our cube root of 3.2, I should be able to find the height of our second can then. Okay, our second cylinder. So 12 divided by my previous answer comes out to be 8.14. Okay, so what would be an appropriate degree of accuracy? These numbers up here are quoted to 2 significant figures, each of them, aren't they? So I'm going to round this one off to 2 significant figures as well. I'm going to say that that is 12 to 8.1. Okay, so my height then is 8.1 to an appropriate degree of accuracy, 2 significant figures, the same as the other in the question. This diagram shows triangles CDE and PQR. There they are. And we're told that CDE is mapped to PQR by combining 2 single transformations. The first is a rotation of 90 degrees anticlockwise about E. Describe the second transformation. Okay, so it's going to be some sort of enlargement or with a fractional scale factor after that. But before we can do or work out the details of where the center of enlargement is, we probably best need to find where that mid triangle is going to be, the one that's halfway between them. So let's carry out this first transformation. That's a 90 degrees anti-clockwise about E. 90 degrees anti-clockwise about E. We're starting with CDE, aren't we? So 90 degrees anti-clockwise about this point here. That means my triangle is going to be, well, the point D is going to end up here. So that's going to be D dash, and C is going to be down there. That's going to be C dash. So we're going to have a triangle here. Okay, and then it ends up there. So what sort of enlargement is that? Well, let's put array lines on. Okay, so joining those 2 points together, we're just matching pairs of points on the object and image together. We should find that they meet in one place, which they do. You can see that they're converging. Oops. On that point there. So that's going to be my center of enlargement, that point at -1, 0. Okay, so it's going to be an enlargement. It's going to be centered on -1, 0. Now what's the scale factor? Now you can see that this side here, the shorter side of my triangle, is 2 in the original image, in the original object, and in the image it's 4, so it's twice as big, but it's also on the opposite side of the center of enlargement, so it's going to be a negative enlargement. So it's going to be scale factor of -2. ABCD is a quadrilateral, and I've got a picture of it there, and I can see the coordinates of each of the vertices, and it says the quadrilateral is reflected in the line x equals 4. Which vertices are invariant? Now, invariant means that when the transformation happens, those particular vertices don't move. Okay, so where is the line x is equal to 4? Now you should remember that a line with the equation x is equal to something is a vertical line through that number. So it's going to be this line here, isn't it? Passing through 4. You notice the x coordinate of c and d are both 4, so that line must pass through there. So obviously my point D is going to be reflected over here to give me D dash, and my point A is going to be reflected over here to give me A dash, but my points C and B lie on the mirror line, so they're not going to be reflected. Well, they are going to be reflected, but they're going to be reflected onto themselves. So the shape's going to end up looking like that, and the points B and C are the ones that don't move. Okay, so B and C are my invariant points, B and C. Here are 4 triangles, and we need to know which 2 triangles are congruent. Okay, now we have certain tests for congruency that we need to know for the exam. The first one, RHS, which is right angle hypotenuse side. Now these are non-right angle triangles, so that one isn't going to be the case. And the others are side, 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 angle, side, and angle, side, angle. Basically what we need to do is make sure we pair up these 3 things on 2 triangles to see if they are congruent or not. And the order that we pair them up is important. So when I wrote down side, angle, side, that's not the same thing as ASS. Not only is that a naughty word, it's also not going to get you the marks. So let's have a quick look at these diagrams. This one here is side, angle, side. So that's one of those. 5, 30, and 3. This one up here, A is not anything. I've got 2 sides, but this is not the included angle, so that isn't going to be congruent to anything. And again, this one down here, that isn't the right way around either. It has to be this one up here. Side, angle, side. So it's B and C that go together. Oops. Let's do that again. B and C. Circle the reason for your answer. It's side, angle, side. ABD and CBD are triangles. BC is 5.6, CD is 8.2, AD is 12.4, angle DAB is 63, and angle DBA is 58. Calculate the angle marked X. Now it's a good idea just to go through and double check everything in the text is actually on the diagram. So BC, that's there. CD, that's on the diagram. AD, that's on the diagram. DAB, that's on the diagram. And DBA, running out of colours, just going to go for purple again, 58. Okay, so they're all on there. The only one I need to find then is X, but I got a feeling I'm going to have to do some work in order to get there. Okay, now in non-right angle triangles, you need to know 3 bits of information to find a 4th bit of information. And then angle in triangle BCD, currently I only have 2, which is not enough. Okay, so I'm going to have to use triangle ABD first, because I've got 3 bits of information in there. I'm going to use those 3 bits of information to find that kind of middle line, this line here, BD. Once I know that, then I've got 3 bits of information in triangle BCD, which I can then use to find X. Okay, hopefully that makes sense. So anyway, I've got to go into, let me just tidy that up a bit because it's a bit confusing. So I'm going to start off with triangle ABD. Okay, which is this triangle here, isn't it? Okay. Now what I want to do is I want to find that common edge of those 2 triangles. So this side here, then that's the one I want to find. So I want to find that side in triangle ABD. Okay, so I'm just going to label up these sides in terms of the letters. So this is, if that's angle A, this is opposite, so that's side A. So that's angle B, so this is side B, isn't it? So what we've got here is 2 pairs of opposite angles. I've got angle A and I want side A. I know angle B and I've got side B. Okay, so what we want to use here is the sine rule, isn't it? Because sine rule is about opposite pairs. So in triangle ABD and using the sine rule, I think it's a good idea to say what it is you're doing. These little short sentences are very helpful to you when you go back and review your work, and also to the examiners. So in triangle ABD, using sine rule, so we know that A over sine A equals B over sine B equals C over sine C. Okay, we only ever use 2 of the 3 parts though. Well, it's D actually, wasn't it? I suppose. D over sine D, I suppose we should have had, but actually we don't need that one. Don't know it, don't care about it anyway, so we're just going to forget about that bit. So I'm going to use A over sine A equals B over sine B. So A is what we're trying to find, sine 63. B is 12.4, and sine B is sine 58. Okay, so rearranging for A, just basically going to cross multiply this sine 63 up here. So I'm going to get A equals 12.4 sine 63 divided by sine 58. Okay, so just a matter of tapping that into the calculator exactly as it is. Just check that your calculator is in degrees. You've got the little D displayed somewhere. If you accidentally set your calculator to radians, that would be very, very sad. Sine 58, that comes out to be 13.028. I'm just going to round that off to 13.0. Okay, so that is 13.0. Okay, centimeters. Now I have rounded it off, but I'm just going to leave that calculated value in the calculator because I've got a feeling I'm going to use it in a minute. Okay, now in my second triangle, now I'm going to switch to in triangle BCD, and this time I've got 3 sides and I want an angle. So if I've got 3 sides and I want an angle, that is the cosine rule. Using cosine rule. So what does the cosine rule state? I'm going to rename that A. It's actually the same thing as C in this triangle, isn't it? Because it's opposite side C. D, that's D there, and then that's going to be B. Okay, so writing the cosine rule in terms of triangle BCD, trying to find angle C, I'm going to say that C squared equals B squared plus D squared minus 2BD cos C. Okay, now you've got 2 strategies with the cosine rule, because there's 2 ways around that you need to find it, either if you're finding an angle or you're finding a side. Either you remember the 2 formulas separately, or you know how to rearrange the formula, so it's in terms of the angle instead of the side, which is what I tend to do. I kind of work out how to rearrange it. So moving the C squared over here and the minus 2BD cos C over this way, I'm going to get 2BD cos C is equal to B squared plus D squared minus C squared. Okay, and then dividing through by 2BD, which will move that down there. I'm going to get cos C equals B squared plus D squared minus C squared over 2BD. Okay. Let's just move this up a little bit, give it a bit more space. Okay, so then putting the numbers in from the diagram, cos C is actually cos x, isn't it? Because I want x. So I'm going to replace cos C with cos x. Cos x equals b squared, 8.2 squared, plus d squared, 5.6 squared, minus c squared, 13.0. But remember, it's still stored in my calculator, so I'm going to use the stored value. divided by 2 lots of B, which is 8.2, lots of D, which is 5.6. Okay, so it's time to carefully type that into the calculator. I'm going to use the fraction key so that I can show what's on the top and what's on the bottom easily. 8.2 squared plus 5.6 squared minus 13.0, which is the answer, my last calculated value, squared, all divided by 2 times 8.2 times 5.6. Okay. Now that comes out to be a fractional answer, but remember, it's negative as well. Minus 0.77. But remember, we're going to be using the inverse cosine of that. So shift cos answer. That comes out to be 140.7. I'm going to round that up to 141 degrees. So x equals 141 degrees. Work out the area of the parallelogram. Now, I've got the base of the parallelogram, which is 16 centimeters, but weirdly, I've been given the slant height rather than the height of this parallelogram. The formula that I know for parallelograms is area equals base times the perpendicular height, which is not what I've got here, so that's not going to work. What can I do instead? Well, I've been given an angle here, so well, I think I'm going to have to use some trigonometry, aren't I? Now I'm going to use a bit of a trick here. I'm going to take my ruler and I'm going to divide this parallelogram into 2 triangles, like so. Now notice that because this is a parallelogram, then that is 16 and that is 12 and that is 72 then, because it's opposite angle in a parallelogram. So I've actually got 2 congruent triangles here, aren't there? They're both exactly the same shape and size. So if I can find the area of one of these triangles and double it, I'll get the area of the parallelogram. Now I do have a formula involving 2 sides of a triangle in the included angle. It's that trigonometry version of it. So the area of a triangle is going to be, well, it's half AB sine C, isn't it? So half of the 2 sides, 12 and 16, times the sine of the included angle, sine 72. So what's that? Reaching for the trusty calculator. Half times 12 times 16 times the sine of 72. It's giving me 91.3. 91.3. But then my area of the parallelogram is going to be my area of the triangle times 2, which is 91.3 times 2. So let's just double that up. Times 2 is 182.6. So that's my answer, 182.6 centimeters squared. ABCDE is a pentagon. Show that BCDE is a parallelogram. Now it doesn't look like a parallelogram in the diagram, but it's not drawn accurately. Now what are the properties of parallelogram? Parallelogram is made up of 2 pairs of equal and parallel lines. In other words, this line here has got to be equal in length and parallel to this line here. And this line here, CD, has got to be equal in length and parallel to this one. So to show that this shape is a parallelogram, all we got to do then is show that this vector here is going to be the same as this one, and whatever the vector is here has got to be the same as this one here. Okay, so if I can show that those 2 pairs of vectors are equal, then I've shown that it's a parallelogram. Okay, so let's start with DE because I've been given that one. I've been given DE. So DE should be identical to CB. So here's C and there's B. Now can I get from C to B along routes that I know about? I can go along here, and I can go along here, and I can go along here. Okay, now they're going against the arrows, but that doesn't matter. Let's find vector C to B. Right, C to B is C to E plus E to A plus A to B. That's the root. Now using the vectors A and B that have been given, C to E is against that arrow, so it's going to be the opposite of that, isn't it? It's going to be minus. So it's going to be minus B minus 2A. I'm going against that arrow as well. So E to A is minus 2B. Minus 2B. And A to B, again against the arrow, so that's going to be minus A. Let's just deal with that bracket. Minus B, minus minus is plus, so that's plus 2A minus 2B minus A. So right, we can start collecting like terms together then. So what have I got? I've got positive 2A and a minus A, so that's going to give me A, and I've got a minus B and a minus 2B, which gives me minus 3B. So my vector C to B is the vector A minus 3B. But hold on a minute, that's the same as the vector D to E, isn't it? A minus 3B. So I can say that is the same as D to E. Okay, so that's the first part done. I've shown that the green lines are equal in length and parallel. Now I need to do the same thing with the yellow lines. So let's take the vector BE to start with, work out what that is. So B to E, well, that's just along B to A and then A to E, isn't it? Yeah. B to A and then A to E, which is, this is a little easy, this bit is a bit easier, isn't it? A plus 2B. A plus 2B, so that one's already done. And we need to compare that with the other one, C to D. What's C to D? Now C to D, I can get along that purple line and then down the green one. So from C to E and then from E to D. C to E and then E to D. So C to E is B minus 2A. Oh, it's going against the arrow, isn't it? So it's minus that. Minus B minus 2A. So minus B minus 2A. And then again, I'm going against the arrow of that one. So it's minus A minus 3B. Minus A minus 3B. Okay, and then we're dealing with all those negative signs. Minus B is just minus B. Minus negative 2A, that's plus 2A. Minus A is minus A. And minus 3B is plus 3B. Okay, now again, collecting up like terms. I've got minus B and a positive 3A. And I've got a positive 2A and then a minus A. So that gives me an A plus 2B, which you'll notice is the same as that one. So again, I can say, well, that is the same thing as B to E. Okay, so just to summarize that, I can say that CB equals DE. So C to B is equal to D to E, and B to E is equal to C to D. Therefore, B, C, D, E is a parallelogram. Okay, cool. Some girls and boys take an exam. Here is some information about the marks for the girls. So we know the lowest is 16, the highest is 78, the lower quartile is 24, the upper quartile is 66, and the median is 48. We need to draw a box plot for that information. Okay, well, that's all very easy. We're going to have a box in the middle. This would be Q1, the lower quartile. This would be Q3, the upper quartile. And Q2 is the median in the middle. And we're going to have whiskers going out to our lowest and our highest value. Okay, that's what it's going to look like. So now we can draw that neatly on the graph. So I'm going to get a ruler and place it on each of these measurements so I get it absolutely accurate. So the first one, the lower quartile, is at 24. So let's mark that on the scale. Okay, and then my upper quartile is at 66, which is there. And my median is at 48. Should be there. Okay, so let's just turn the ruler around, complete our box. Oops. Okay, so there's my box part, and now the whiskers are going to go out to the highest and lowest values. So the lower whisker is going to go down to 16. So 16 is here. And then the the highest value goes up to 78. Should have done it that way around so I can see the scale at the same time. And the upper whisker goes up to 78 there. Okay, so that's my diagram complete. The cumulative frequency graph shows the distribution of the heights of members of a rowing club. The first part says find the median. Okay, so the median is the middle one. We've got 120 people altogether. So halfway through that would be the 60th person. So in order to find the median, we're going to read off from 60 and then down. Okay, so find 60 on our cumulative frequency curve scale. Read across to the graph, switch directions, read down to the axes. Now I make that, oops, around about 172 centimeters. 172 centimeters. Now the interquartile range we can do in a similar way. So 60 was halfway through my data, so the quartiles lie 1/4 and 3/4 of the way through. So 1/4 of the way through 120. 120 divided by 4 is going to be 30. So my numbers went a bit weird when I printed the scale off, but it should be here. Find 30 on a scale. For some reason when I reproduce this graph, my numbers went a bit wonky on the axes. But hopefully they're good on the copy that you're using. So read across from 30, and then 3/4 of the way through. 30 times 3 is 90, isn't it? So I'm going to read across from 90. So find 90. Read across to your curve. Change direction. Read down. Okay, so my lower quartile Q1 is going to be 160, and Q3, my upper quartile, I'd say that's about 177. So Q1 is, so Q1 is 160. Q3 is 177. So the interquartile range is going to be Q3 subtract Q1, which is 177 minus 160, giving you, what's that, 17? And then finally it says calculate the percentage of members who are at least 180 centimeters tall. Okay, so far we've been reading the cumulative frequency across and then down to find the actual heights. This time we're going to have to go the other way around. So we're going to have to find our height of 180 centimeters, which is here on the graph. And this time we're going to read up to the graph and across. Okay, so reading up from 180 till we hit the curve, and then turning and reading across. That seems to be bang on 100 for mine. Okay, so that is the number of people who had a height of 180 or less. So we want to know the percentage of members who are at least 180 tall. So actually what we want is these people who are taller than 100. Okay, so we want these people here. So what's that as a percentage then? The number who are 180 degrees or taller are going to be these people. How many people are there between 100 and 120? There are 20 of them. Okay, how many people are there altogether? 120. So what is that as a percentage? It's going to be my 20 people who are taller than 180 or as tall as 180, and then over everybody. What's that then as a percentage? And then times by 100 then, isn't it? Oops. To get it as a percentage, so 20 divided by 120 times by 100 comes out to be a 16.6 reoccurring. I'm going to round that up to 16.7 then. So that's 16.7%. 16.7. The histogram summarizes the heights of 153 members of a swimming club. And the question is, which club has the greater median height? You must show your work in. So from the part A, we know that the rowers' median height was 172 centimeters, wasn't it? Okay, just fell off a little bit. Let's move it over. Right, so that the rowers was 172. So what is the median now then of the swimmers? So who is the median swimmer then? If we've got 153 swimmers, if we add 1 and divide by 2, that will tell us where to find the median swimmer. So 153 plus 1 is 154, divided by 2 is the 154 divided by 2, what's that, 77th? That's going to be the 77th swimmer. Okay, so where is the 77th swimmer here? Okay, now we've got a frequency density here, so what we need to work out is how much each of these bars is worth next, I think. Okay, so what is the total area of all these bars? That should be equivalent to 153. So this first bar is 1.4 times length at the bottom is 20. 1.4 times 20. What's that? 1428. So that's 28 people in that bar. This next one here is,
and therefore the rowers have the highest median.
Width of 10, so 7.4 times 10, that's 74 people in there. Okay, so I can see already that the median swimmer must be in this big tall bar then, isn't it? So if the first 28 people are in this first bar, then this middle bar then starts from the 29th person and goes up to 74 plus 29.
So we can say that the median for the swimmers definitely lies in the 100 to 60 to 170 range. So I don't know exactly the value of the median for the swimmers yet, and I don't think I actually need to find it, because no matter where it lies in that range from 160 to 170, it's definitely less than the median for the rowers, which was 172. Okay, so I think I've done enough already, so I can just say that the median must lie between 160 and 170.
So the rowers have a greater median.
Work out the size of angle X. Now I've got a non-right angle triangle here, so it's going to be, and I've got angles and sides, it's going to be trigonometry, but it's not going to be right angle trigonometry, SOHCAHTOA. It's going to be either the sine rule or the cosine rule I'm going to have to use. Now, do you know how to decide between the two? Sine rule is about opposites. You need opposite pairs, and the cosine rule is about two sides and an included angle, or three sides looking for one angle. So here we've got opposites, haven't we? What I mean is I've got this 125 here and it's opposite that 14, and I've got this x here and it's opposite that 6. Okay, so it's going to be the sine rule. Sine rule is about opposites. So sine, we want to find the x, don't we? We want to find the angle. So we're going to state the sine rule with the angles on the top. Sine A over A equals sine B over B. So sine x over 6 equals sine 125 over 14. Okay? So just need to rearrange that now then. So take that 6 and move it up there. So we get sine x equals sine 125 times 6 over 14. Okay, so it's time to reach for our calculator. 6 sine 125 equals, divide by 14 equals inverse sine answer equals 20.55. Now I normally give angles to one decimal place, so that is equal to 20.6 degrees. A stone is thrown upwards with a speed of v meters per second. The stone reaches a maximum height of h meters. H is directly proportional to v squared, where v is, and when v is 10, h is 5. Work out the maximum height reached when v is 24. Okay, so we've been given this. H is directly proportional to v squared. So I can write that down mathematically as h directly proportional to a little fishy v squared. So h little fishy v squared. Now then I can replace that proportionality symbol with equals k. So h equals k lots of v squared, where k is some constant that I can find straight away. Normally with these, well always with these really, they give you a pair of values that go together. That pair of values is specifically for evaluating your value of the constant. So let's sub those in. So when v is 10, h is 5. So subbing those in, 5 equals k lots of 10 squared. So you can see the only thing we don't know there is k. So 5 equals 100. K, give me k is 5 over 100, or 0.05. So that's my value of k. So once I know what k is, and I've got the complete equation that links h and v together, so then h is going to be 0.05 v squared. Now students often mix up what is a constant and what is a variable in these sorts of equations. H and V are both variables and they can take multiple values within the question. K is a constant and it has only one value, and once you find it and replace it, you don't have to think about K ever again. So I've got my complete equation in H and V, which I can now use for the remainder of the question. So the last part of the question then says work out the maximum height reached when V is 24. So we don't have to work out the maximum height. All we've got to do is sub in the value V is equal to 24 into this equation and work out what the answer is. So that's what we're going to do. When V equals 24, then H is going to be 0.05 times 24 squared. Trusty calculator time. 24 squared times 0.05 gives me a height of 28.8 meters. So that's my final answer, 28.8. Y is inversely proportional to the square of x, the square root of x. Y is 40 when x is 9. Find a formula linking x and y. Okay, so very bog standard, straightforward proportionality question. This first thing here tells me the relationship between y and x. So y is inversely proportional to 1 over the square root of x. So y is proportional to 1 over root x. Okay, that's the relationship between y and x. Now I can replace the little fishy symbol or the proportionality symbol with equals k. So k times 1 is just k over root x. So the equation is going to be of that form, y equals k over root x. Now they always then give you a pair of numbers that go together, and the reason they give you that is that you can then evaluate your value of k here and find the complete equation. So we're going to do that bit next. So when y equals 40, x is equal to 9, so we're going to plug those two numbers in. So 40 is equal to is equal to k over root 9 then, isn't it? Okay, square root of 9 is 3. Multiplying both sides by 3, you're going to get k is equal to 120. Okay, so once I know that k is 120, I can then complete my equation then. So complete formula is y equals 120 over the root of x, like that. That's the complete formula. Okay, so very, very standard. They give you the relationship, they give you a pair of values to work out what k is, and then you do that, and then you write down the complete formula for the 3 mark. Here is a velocity time graph of a motorbike for 25 seconds. After how many seconds was the acceleration 0? Okay, well the acceleration is going to be the gradient of the velocity time graph, and the acceleration is 0 when the graph is flat. So you can see, where is it flat? It's going to be flat here at this point here, or more in particular right in the middle of there. So at that point there, look, it's flat. So reading down to the graph, reading down to the axes below, it's there, isn't it? Now that is, well, you can see I've got 10 divisions between 0 and 5, so each division must be a half, or 2 divisions, or 2 little squares is 1. So I make that 6 then. So after how many seconds was the acceleration 0? It's going to be after 6 seconds. And then it says work out the distance travelled in the last 15 seconds. Now distance travelled is the area under a velocity time graph, and the last 15 seconds is So 25 seconds less 15 is 10. So it's this section here. Right. Sort my pen out. So from here down to here. Now you'll see that this section of the graph is a straight line. Can't seem to draw on there. Okay, that's it. So this section here we're looking for. Okay, so that's the section of the graph is a straight line. So the shape we've got is a trapezium. So the area of a trapezium is going to be the two parallel sides added together divided by 2 times the distance between them. So this is my A value here, isn't it? Which is of a height 22. So A is 22. This is my B line on the other side. That is at a height of, I make that 18. The distance between them is this distance. We said for the last 15 seconds. So it's that 15 there. So distance travelled is going to be a half A plus B times H, the formula for a trapezium, which was a half of 22 plus 18 times 15. Got those right? 22, 18, 15, yeah. So half of 22 plus 18. 22 plus 18 is 40 divided by 2. So half times 40 times 15. Half of 40 is 20. 20 15s are 300. So it's 300 meters. Lucy makes 5-digit number cards using all of these cards. 3, 4, 6, 7 and 9. So how many different numbers greater than 50,000 can she make? Okay. So let's consider her choices. If she's going to make numbers bigger than 50,000, then there's a restriction on her first selection of her first digit card. She can only pick one of these 3 to start off with then. So she's got 3 choices for her first selection. For her second selection, doesn't matter which one of those 6, 7 or 9 she picks, she'll have 4 other choices for her next digit number. Then she'll have 3 choices for her next digit and 2 and then 1. So the total number of selections that she's got is going to be 3 times 4 times 3 times 2 times 1, which is 72 choices. 21 people travelled to a meeting. 12 used a train, 6 used a car, 7 did not use a train or a car, some used a train and a car. 2 people are chosen at random from those who use a train. Find the probability that both these people also used a car. Now, when you've done enough past papers, and if you've done as many as I have, it should be screaming to you what sort of question this is. Maybe it isn't just yet, but this is a Venn diagram question, really. It's the easiest way to kind of summarize this information and find out the bits of information that we need. Okay, so with Venn diagrams, I've got 2 sets here. I've got people who used a train and I've got people who used a car. I know that 12 people used a train altogether, 6 people used a car altogether, 7, I'm not going to put those on yet because I don't know what's in the middle. Okay, so I'll come back to those. 7 did not use a train or a car, so I know that 7 lies outside the 2 circles. Okay, so there's my Venn diagram, set of everything. Okay, so, and some used a train and a car, so there's definitely people in the middle. Okay, and we know that everything is 21 altogether, so we need to work out really what that x is in there in the middle. We need to find that first, and then so the people who used train only is going to be 12 minus that value of x, and the people who used a car only is going to be 6 minus that x, so that you've got 6 altogether, and we know that everything in there equals 21, so we're going to use that to find the missing x value. So we're going to form an equation in X and solve it, because I know that all 4 of my regions is everyone and everyone is 21 people. So my 12 minus X region plus my X region plus my 6 minus X region plus my 7 region, all added up must be equal to 21.
which is everybody. Okay, so collecting like terms, I've got 12, 6 and 7, and I've got minus x and minus x. So let's just add those other up. 12 and 6 is 18 plus 7 is 25. So 25, and I've got minus x plus x minus x, which comes to minus x equals 21. Okay, so adding x to both sides, taking 21 away from both sides, I'm going to get 4 is equal to x. Okay, does that make sense? Hopefully it does. So that means that there must be 4 in the middle, which means I've got 8 in this one, which means I've got 2 in this one. Okay, just double check it all adds up. So 4 and 2 makes 6, which is the number in the who used a car. 8 and 4 makes 12, which is the total used a train. 8 plus 4 plus 2 plus 7 adds up to 21, which is the total. So that seems to work. Okay, so now I've completed the Venn diagram, I can actually go on and answer the actual question that they asked. 2 people are chosen at random from those who used a train. Now, those who used a train are these people over here. So these are the people that I'm picking from. Okay, only these people. So how many people is that altogether? That's 12 people altogether. So I'm picking from these 12 people, and I want to find out the probability that they both also used a car. So what's the probability? If I pick 2 at random, they're both going to be in this section here. Okay, so I'm going to do that using a tree diagram, because this is the other more complex sort of picking selections. It's what we call dependent probability, or probability or selection without replacement. So if you think about it, I'm picking then whether or not they have a car or used a car or didn't use a car as well as the train. Okay. So what's the probability on the first selection that my person used a car? Well, there are 4 people who also used a car out of a total of 12. So the probability that the person I picked at random used a car is 4 out of 12. So the probability that they didn't use a car then is going to be 8 out of 12. Those who didn't use the car, only train. Okay, now in my second selection the probabilities are going to depend on the first selection. So it's still going to be car, no car, car, no car. But the number of people I'm picking from now is 1 less, because I haven't replaced the person I'm picking from. I've got 1 less person to pick from. So the fractions are all going to be out of 11, because I've got 1 less person to pick from. And if I've already picked one of the people who used a car, the probability of picking a second one that also used a car is going to be 1 less, isn't it? I'm going to have 3 out of 11. Okay? If I got picked by car, then I've still got 8 who didn't use car here at this point. Now, if I go down the other branch, if I didn't pick someone who didn't use a car first time, then I've still got all 4 who did use a car to pick from, but I've got 1 less person who didn't use a car to pick from. So this is dependent probability, and each branch of my tree diagram is going to have different probabilities on it than each other. Okay, so it's a little bit more complicated. So find the probability that both these people also used a car. So I want probability of car, which is this route through my tree diagram. So basically I need to multiply this and this together then, don't I? So probability of car is going to be 4 out of 12 times by 3 out of 11, which is 12 out of 132. Yeah, which cancels down, doesn't it? That's 1 out of 11. Now I've actually done something here that I often advise people not to bother with, which is cancelling down fractions in a probability question. Unless it says express it in the lowest terms, often you just get full marks by getting any probability. So you could just leave your answer as 12 over 132 and get full marks. If you do cancel down, know that you're not going to get any extra credit for it, so you're going to get no more marks for doing it, and there is a possibility that you do it wrong, and if you do it wrong you're going to lose a mark. So if you do cancel down, you're going to get the same marks or less than if you just bailed out at this point here. Okay, so cancel down at your own risk.
A bag contains 12 discs. 7 are red, 3 are blue and 2 are yellow. 2 discs are taken from the bag at random without replacement. work out the probability that two disks are the same color. Okay, well, it doesn't tell you to do this, but this lends itself quite well to a tree diagram. Although it's going to be quite a busy tree diagram because we've got 3 branches for each of the 2 selections. So anyway, let's draw it. So first selection has got 3 branches, and then our second selection has got 3 branches. So our tree diagram is going to look something like that. So what are the colors? We've got red, blue, yellow, and then second selection red, blue, yellow, red, blue, yellow, red, blue, yellow. Okay, now we want the probability that the 2 disks are the same color. So it's either red, red, blue, blue, or yellow, yellow. Let's just put the probabilities on. Now we've got 7 red disks out of 12. So the probability of going down the R branch is going to be 7 out of 12. Then for B, that's 3 out of 12, and yellow is 2 out of 12. Now your second selection is going to be dependent on your first. If I picked a red the first time around, we've still got our 3 blue and our 2 yellows to select from, but we've got 11 choices to select them from this time. But we'll have 1 less red, so that will be a 6 out of 11 there. If I pick blue first time, I'll have 1 less blue, so I'll have 2 blues to pick from out of 11. I'll have the same number of reds I had to start with, so that's 7 out of 11, and the same number of yellows I had to start with, which is 2 out of 11. And then finally, if I pick yellow the first time, I'll still have my 7 reds out of 11. I'll still have my 3 blues out of 11, and I'll only have 1 yellow left. So it'll be 1 out of 11 there. Okay, so adding all our probabilities on, it's now a matter of working out what all those values are going to be. So the probability then, we're looking for the probability that the 2 disks taken out of the bag are the same color. So the probability that they're the same color, now that's the probability of 2 reds, so that's equal to the probability of red red plus the probability of blue blue plus the probability of yellow yellow. Now let's take the first one, probability of red red, that's a red selection followed by a red selection there, so that's 7/12 times 6/11. So that's equal to 7/12 times 6/11. Now plus our second selection, our second way of doing it would be blue blue, which is blue followed by blue, which is 3/12 and 2/11. So 3/12 times 2/11, and then finally 2 yellows, yellow followed by yellow, so 2/12 and 1/11. So the probability of yellow yellow is 2/12 times 1/11. Okay. Now, 12/11s, what's that? That's 120, 132. So it's going to be a fraction over 132. I've got 7 times 6, which is 42. I've got 3 times 2, which is 6. And I've got 2 times 1, which is 2. So 42 plus 6 plus 2 is 50. So my probability should be 50 out of 132. Now, you could, of course, have done that on your calculator as well. I tend to just do it mentally because I can do it quicker than tapping it in, and I think I can do it more accurately, but it's up to you. You don't get any extra credit for cancelling down probability questions for some bizarre reason, so you can just leave your answer as it is.
Phew, well that was a long session. Well done for getting all the way through to the end. Please do like and subscribe if you found it helpful, and share the link with your friends. This really helps the channel out. Past paper practice is one of the best forms of revision in the run-up to the exams, So be sure to check out my past paper walkthroughs by checking out the playlist linked on your screen. See you on the next video.